Hello everybody, welcome to another lesson by me, Miss Pythagoras. In this lesson, I will explain the proof of the double angle for sin 2a. All the three proofs of the double angle cos 2a as well as plenty of examples. This is lesson 5 of 5. Have you subscribed yet? You can also visit my website onlinemaths.co.za. The link is in the comments below. There you will find all the chapters in the syllabus. Let's start with the maths. I will start with the formula for sin 2 alpha, the double angle. There's the formula sheet and you find it there. Sin 2 alpha is equal to 2 sin alpha cos alpha. So let me show you where it comes from. Sin 2 alpha is the same as sin alpha plus alpha. And then on your formula sheet, you've got the compound angle sin alpha plus beta. So that one you can write as sin alpha cos alpha plus cos alpha sin alpha. And then it's as if you've got AB plus AB is 2AB. Therefore, you can add those two and you end with 2 sin alpha cos alpha. The formula for cos 2 alpha, the double angle cos 2 alpha. Now, on your formula sheet, there's 3 rules. Let me show you. We start with cos 2 alpha and we write it as cos alpha plus alpha, the compound angle. And then that compound angle is the same as cos, cos, sin, sin. And remember, if this is a plus, then that is a minus. And then cos alpha times cos alpha is cos squared alpha, minus sin alpha times sin alpha is sin squared alpha. Now you see that there's 3 rules on the formula sheet. So let's go to the next one. We use the cos 2 alpha, the double angle cos squared alpha minus sin squared alpha to get to the other ones. But there's something from grade 11 that we call the squares identity. Sin squared alpha plus cos squared alpha is equal to 1. And remember, you can make sin squared alpha the subject of the formula by letting cos squared alpha walk across. So what is happening now, in the place of the sin squared alpha, I'm going to substitute the squares identity. 1 minus cos squared alpha. And then I'm going to multiply in the negative there, and I end with cos squared alpha minus 1 plus cos squared alpha, and cos squared alpha plus cos squared alpha is 2 cos squared alpha minus 1. And then the last rule there, again we start with cos 2 alpha and you use cos squared alpha minus sin squared alpha, the first one you worked out. Again, back to your squares identity. Now, if you get, or rather if you make cos squared the subject of your formula, it's the same as 1 minus sin squared theta. So into your double angle here, in the place of cos squared alpha, you can substitute the squares identity. 1 minus sin squared alpha. And then minus sin squared alpha minus sin squared alpha is equal to 1 minus 2 sin squared alphas. So there's the proof of your 3 double angles for cos. Use the double angle formula to expand the following. Again, there's our formula sheet. So let's start with sin 2 theta is the same as 2 sin theta cos theta. Sin 50 is the same as 2 sin 25 cos 25. So please note, if this is the double angle 2 theta, then this is single or half of 2 theta. Now this is the angle 50 and then this is 25 degrees, 25 degrees. So sin 4b is the same as 2 sin, and then if this is 4b, this is 2b cos 2b from using the formula. Now let's go to cos 6b. Cos has three options there. So if we use the first one, we write it as cos squared minus sin squared. And then this is 3b, 3b. It's half of the 6b. Or if we want to use the second formula for the cos double angle, we can write it as 1 minus 2 sin squared 3b. Or if we want to use that one where the green arrow is, the rule 2 cos squared alpha minus 1, you can write it as 2 cos squared 3b minus 1. Now let's look at cos 80. So using the first rule, we can write it as cos squared 40 minus sin squared 40. Can you see? If this was 80, then the two angles there is half of 80. Or if we use the 1 minus 2 sin squared alpha, we've got 1 minus 2 sin squared 40. And if we want to use the 2 cos squared alpha minus 1, it is 2 cos squared 40 minus 1. Write as the sine or cosine of a single angle. So when I give you 2 sin 3a cos 3a, that one is the same as sin 2 3a, which is sin 6a. Then the next one, 4 sin y cos y. 4 can be split up into 2 times 2 is 4, and then there's the 2 sin y cos y, which is the double angle, and then this 2 is that 2, and then 2 sin y cos y is the double angle for sin. The next one, cos squared b minus sin squared b, that is the cos double angle, so the answer cos 2b. The next one, 1 minus 2 sin squared a is the double angle for cos, and it is cos 2a. Then the next one, you must be very careful with this 2 alpha there. It is in fact cos 2 alpha, which is cos 4 alpha. Remember, if this is an A, this is double A. If this is a B, this is double B. So if this is 2 alpha, then this is 4 alpha. And then the last one, the sin squared p minus cos squared p, it feels as if it's the rule for the double angle, but it's not, because the rule for the double angle, you find the cos squared first. So what you have to do is you have to swap those two around. And then you end with minus cos squared p plus sin squared p. But now there's a plus. So what you have to do is you have to factorize by pulling out the minus as a common factor. And then you end with minus bracket cos squared p minus sin squared p. And only now it's the double angle for cos. So therefore the answer is minus cos 2p. Simplify without a calculator. Cos squared 75 minus sin squared 75. Can you see it's the double angle cos 2 alpha? So therefore it's cos 2 times 75, which is cos 150. And then what to do with cos 150 is grade 11 reduction formula, where you can write 150 as 180 degrees minus 30, and when you reduce that one, it becomes minus cos 30, which is minus root 3 over 2. Simplify without using a calculator. Sin 66 over sin 22 degrees minus cos 66 over cos 22. Here you will find the LCD, and the LCD is sin 22 cos 22. To go back, on the first term, this one you will multiply by cos 22, and the second one you will multiply by sin 22, and then on top of the LCD. So then you end with sin 66 cos 22 minus cos 66 sin 22. And can you hear the pattern there? Sin, cos, cos, sin. And that is the compound angle for sin alpha minus beta. So on the numerator you can write that one as sin 66 minus 22. Then over sin 22 cos 22. 66 minus 22 is the same as sin 44. And what can you see there? Sin 44 is the double angle sin 2 alpha. So you can write sin 44 as 2 sin 22 cos 22 over the sin 22 cos 22, and they can cancel out, and your final answer is equal to 2. If cos 25 is equal to k, write sin 50 in terms of k. Now I think this is a familiar sum by now. So you start with the given angle, the cos 25, and you give yourself a help sketch and you add 25 there in standard position. Then if there's nothing, it's k over 1, and cos's ratio is x over r. Therefore, in x's place you substitute k, in r's place you substitute 1. Again, you are looking for y, and you use the theorem of Pythagoras. Y squared is equal to r squared minus x squared. In r's place you substitute 1, in x's place you substitute k. Therefore, you don't want y squared, you want y. So you take the square root, and then y is equal to root 1 minus k squared. Now you've got everything. Let's go back to the sum. The sum was sin 50. Then you're going to write the 50 in terms of 25 by writing sin 50 as sin 2 times 25, the double angle for sin. And then that one is the sin 2 alpha, which is 2 sin 25 cos 25. And then in sin's place, sin 25, sin is y over r, which is root 1 minus k squared over 1, and cos 25 was given that it's k. And then in the last step, you can only put the k together with the 2 in front, and the answer 2k root 1 minus k squared. This is the end of double and compound angles. There is also a playlist for trig identities and equations. Click on the video in the left-hand corner to take you straight to the next lesson of the playlist. This is Miss Pythagoras signing off till next time.